If you search stacks in Google, these are the images that will pop up. A stack data structure is very much similar to what a stack means in everyday life. Something is organized one on top of the other. The most common example on how to explain stacks is the plate analogy. Stacks in computer science is basically just the same as what stacks of plates are. In computer science, a stack is just a data structure. It's just another way of storing data. Let's say in a simple situation you want to give your computer some data. So the computer stores it in a data structure called stacks. So what the computer does is that it places the first element here at the bottom, and then it places the next element on top of it, and then we add the next element, or should we say stack the other element on top of it, and then we add the four or stack it on top of the other. A stack can be taken quite literally. Now, let's change our example into a bunch of rocks. Here, there are a bunch of rocks stacked on top of the other it's an organized pile, balanced one on top of the other. We can put another rock on top of it, or should we say push, or we can take one rock on top, or should we say pop. However, we can never take a rock in the middle or add another rock in the middle, else the pile of rocks would collapse. Just like how the rule of physics apply to literal stack in real life, the same rule applies in stacks in terms of data structure. And this rule is what we call as the last in, first out principle. The very last element that went in is the element that is in the last or in the bottom part, while the very first one to go out is the elements that are on top. And that's just it. That's what stack data structure is like. It's just like what stacks are in our physical reality. And now that we understand what stacks are, let's try and implement it. Here, I have a code. It's my version of a pseudocode of how to implement a very simple stack through an array. But let's not focus on that. Let's translate the code in a more natural way. The first code here basically just says that I want to create a storage space for 5 items later on. And let's say, for the sake of this explanation, let's say that you are in an empty room. So you create 5 storage space, or let's say boxes. And you also might be wondering that the example earlier were stacks of plates and box, but now we are using boxes. This is just the same rules apply. We're still talking about stacks, but we're using this because this is how arrays look like. We're doing this just to visualize it. As you can see, this part here is how it looks like in formal code. It's like an array in formal code. The next part of this code here just creates a pointer. For our sake, let's visualize this pointer as a robot. Let's place the robot somewhere here. And for the sake of this explanation, let's put labels for our boxes starting with 0, 1, 2, 3, and 4. We start with 0 because that's typically how things are labeled or indexed in computer science. Let's label the outside, or let's label where the robot is at as of now as space number -1. The pointer, or in our case, the robot, will be the one responsible for placing the data in the boxes in the future. The next thing that we are going to do is to create an instruction of what will happen if we want to insert a data or an item to the box. So what we are going to do is change the position of the robot if we want to add an item to the boxes by adding 1 to change the position. From -1, if we add 1, it will go to position number 0. Now, when we want to push, or let's say add an item, the robot will drop that item or place that item on that specified location. In this case, since the robot is already on spot number 0, it will put that item on spot number 0 or in box number 0. And let's say we want to keep adding another number, so we add another item to our stack. We go back to the code where we want to change the position of the robot so that the robot will change position and drop the item on the next spot or in the next box. So the robot will place the item or the data in where its spot is. And for this case, it's on spot or in box number 1, so it will drop the item there. And now let's go back to our code or let's go back to our situation. Let's go back to making instructions. And now, if we want to remove an element or data or an item, the next thing that we're going to instruct is what we will do when we want to remove the item. So we are going to say that we want to take the item of where the pointer is, and in our case, where the robot is. So we pop or remove or take the item of where our robot is. Once we have taken the item, we are going to subtract the position of the robot by 1, so the robot in our situation will go back to box number 0. And now we're done. This implementation is the simplest way of visualizing of how we implement a simple stack in formal code. And now let's talk about the application of what stacks can do in real life. So in software, stacks can be used to reverse a word. Let's say we have the word cat, and let's say we want to reverse it. So we use the stack data structure. So we put C first, the first letter at the bottom, and then we stack the next letter A, then we stack it, the next letter T, and then we remove it. And we remove the top item first, and then we remove the next item, the middle one, and the last item, which is in the bottom, or the C, and now we reverse cat. Some other examples include the undo button, and another is about how computers or system schedule tasks.